My name is Tan Suling. This is my individual EBS recording for the Applied Economic Tricks individual assignments. First, I will start from the Excel data. The dividend variable is LNGDP, which represents a Malaysian economic growth. The independent variable is LN domestic credit, LN gross fixed capital, and LN trade openings. So now you open the EBS and create a new EBS workflow. So the workflow structure type, I choose the date regular frequency, and that specification frequency, I choose annual. The start date is 1994 and the end date is 2024. Then I click OK. So now I will create a new object for the dividend variable and independent variable. So now I create them as a group. Copy the data from the Excel. After entering the data, I run the unit test. So I double click the LNGDP and go to view. I choose the unit test and the standard unit test. For the test type, I choose the argumented decouplers and the test of unit root in label and include in test equations intercepts. So the probability value is 0.7614, which is greater than 10%, so it is not significant. Then I test LNGDP.
Now I repeat the same step.
And choose a unit root test and standard unit root test. And test for unit root in first table. So you can see the probability value is 0.0003, which is significant.
Then I repeat the same step again, choosing the unit root test and then the standard unit root test. The test of unit root remain the same and include in test equation. I choose trend and intercept.
So then I click OK. So you can see the probability value is 0.0020, which is significant. And now I choose the unit root test and the unit root test. So the test for unit root in label and include in text equation remain the same. So you can see the probability value is 0.7018, which is not significant. So after that, I repeat the same unit root test for the independent variable. For example, for LNDC at label with intercept. So you can see the probability value is 0.4430, so it's not significant. So after the first difference with the intercept, the probability value is 0.0033, so it's significant. So for the LNDC, LNDC with trade intercept and the label without has a probability value of 0.6016, so it is not significant. So after first difference with the train intercept is 0.0198, so it is significant. Next, I run the OLS estimations. I select LNGDP as the dependent variable, and the LNDC, LNGFC, and LNTO. So then I open them as equations and choose the least square as the estimations method. In the OLS output, I mainly look at the coefficients, probability value, R square, and prob F statistic. The probability values for LNDC, LNGFC, and LNTO are all below 5%. So these variables are statistically significant. However, all three coefficients are negative. This means the variable has a significant effect on economic growth, but the direction is not consistent with our expected positive hypothesis. So you can see the R square is 0.897623, which means the model explains about 89.76% of the variations in LNGDP. The Pro-F statistic is 0.00, which shows the overall model is statistically significant. And then I run the diagnostic test. First I go to view and choose the residual diagnostic and choose the histogram normalities. So here the probability is 0.339142, which is greater than 5%, so the residuals are normally distributed. Then next I will run the serial correlation test. The probability value of the F statistics is 0.1396 and probability values of chi-square is 0.1045. Since both values are greater than 10%, there is no serious serial correlations problems. Then check the multicollinearity using the various inflections. So I focus on the central VIF values. The central VIF values for LNDC, LNGFC, and LNTO are all below 10, so there is no serious multicollinearity problem.